Hello students, hope you all are doing fine. So today let's start our chapter number 1, rational numbers. So first of all, let's see the types of numbers. So how many types of numbers you already studied in this one before this? So how many types of numbers you are seeing here? So you are seeing natural number, then whole numbers, then integers. So natural number, whole number, and integers, these are nothing but the number system. Means exactly these are containing positive numbers, 0, and as well as these are the positive numbers. This is 0, and these are nothing but containing negative 0 and positive numbers. So then after that, we going to study next type of numbers. So what is the next type of numbers? We can call that number as a rational number. So what is this exactly rational number means? And what is the form of this rational number? So let's see. So this rational number including all natural numbers, whole numbers, as well as integers. What is the form then? The form is P by Q. P by Q means nothing but your fraction form. You can see your fraction. After that, again one more condition is there. The main and important condition of this rational number is Q is not equals to 0. What is Q here? Q means nothing but 0. So your denominator is not equals to 0. So whenever the number is in the form p by q as well as your denominator is not equals to 0. So such type of numbers we can call as rational numbers. We can call as such type of numbers as rational numbers. Okay. So let's see the examples. The examples and each. So 5 by 3 minus 2 by 5, 1 by 7. So why these negative numbers are there? Yes, because the rational number including natural numbers, whole number, as well as integers. And as we have seen, integers means containing positive as well as negative numbers. Isn't it? Then again, through this Venn diagram, we'll see what is the exact structure of numbers. So first of all, our system starts with natural number. Number system always starts with natural numbers. These are naturally occurring number 1, 2, 3, and up to infinity. Then when in this natural number 0 is included, so such type of numbers are called as full numbers. Again, after considering natural number whole numbers, if we are again adding the negative numbers in that one. So when we are adding the negative numbers, then that is nothing but known as integers. So integers, we can say in other words, integers containing whole numbers as well as natural numbers. And the last type is nothing but the rational number. So what is this rational number? As we can see, this is in the form b by q. Denominator is not equals to 0, and this rational number contains the terms of integer as well as whole number and as well as natural number. So this is nothing but all about the rational number and the definition and the form of that rational number. So let's see few more examples of this rational number. So few more examples of rational numbers are here. It is given. Again, definition is mentioned here. First of all, just go through with this numerator and denominator. These are nothing but your integers. These are nothing but your integers. Again, as we discussed, integers nothing but your negative numbers are negative as well as 0 and as well as positive numbers are. So all these numbers are included in integers. What about in the first example? Your numerator is 5 and denominator is minus 3. Yes, both we can say both are the integers and denominator is minus 3, not 0. And again, the satisfying the condition of rational number. This is the main condition. The denominator must not equal to 0. And therefore, this is nothing but are example of a rational number. Next, same second one, yes. It is again a rational number. Why? Because 0 by 1. What about 0? Is 0 is an integer? Yes, so this 0 is an integer. And then what about denominator? 1. Yes, 1 is again there. 1 is again in the form of integer or included in integer. So therefore, whichever number is there, this is the number of rational number. Next, 3 by 0. What about this 3 by 0? Is this your rational number? No. This is not your rational number. Why? Because when we are saying 8 without 3 is a rational number, 0 is again a rational number. Numerator and denominator both are the rational number. But what about denominator? For the main condition of a rational number, denominator should not be equal to 0. And here your denominator is 0. And therefore, this is not a rational number. Isn't it? So, third is not example of rational number. Then the next one, four. This is again the rational number. So, let's look at the next topic of rational number. I hope now you have understood what is the definition and what are the criteria we need to rational number. Then, next. The standard form of fraction. Fraction, or we can call that as a rational number again. Fraction, in the fraction form, we can get a rational number. So therefore, now we need to find out the standard form. What is the exactly standard form? So whenever your rational number is given to you, so what is the rule or what are the steps? We need to reduce that in the standard form. So rules are nothing but first and the important rule is there. If whichever fraction is given, if you need to convert that into the standard form, so numerator and denominator must be of co-prime numbers. Means they do not have any common factor other than 1. So your numerator and denominator are co-prime. The meaning is given here. What is a co-prime? Not a common factor other than 1. And then next is the denominator should be positive. What about the denominator? The denominator should be oh, whichever the denominator is there, that denominator is again a positive number. If it is negative, suppose this thing, the for example here, minus 5 by 10. Sorry, 5 upon minus 10. So in step 1, we are going to perform some operation on this one and we need to follow the rules as well. So what are the rules again? Go through that rules. The numerator and denominator must be of co-prime number and denominator should be positive. So first of all, with the denominator here, the denominator is negative. So that's why the first step that we are going to perform is we are multiplying and dividing the numerator as well as denominator by minus 1. When we are multiplying by minus 1 numerator and dividing the denominator, what happens? So, whichever that number is there, with minus multiplication, that negative sign now comes to numerator. And therefore, your term is nothing but minus 1 by 10. Your term is nothing but minus 1 by 10. Then in step 2, what we need to do is divide by the common number. What is the common number in this one? We are dividing by 5. Why we are dividing by 5? Because the numerator and denominator are co-prime, must be of co-prime numbers. And therefore, so 5 and 10 comes in the table of 5. So that's why we are divided by 5 and after division, the number is minus 1 by 2 and this is nothing but called as the standard form of minus 5 upon minus 10. This is called as the standard form of 5 upon minus 10. This is standard form minus 1 upon 2. So again we are going to repeat the numerator and denominator must be of co-prime and as well as the denominator should be positive. So if it is not in that form, then we need to convert in the standard form. This is the standard form of fraction. Again, look at the second example and the form. So what about the second example? There is no as such negative sign. So therefore, there is no need to multiply by negative sign. But 2 and 4, again, these are not co-prime numbers. And therefore, we are going to divide both this by 2. Then we are dividing this by 2. The answer is 1 by 2. And yes, 1 and 2 both are co-prime numbers. Similarly, your third example, negative sign is there in numerator. So there is no need to multiply this by negative sign to numerator as well as to denominator. And therefore, only we are going to divide this by. When we are going to divide this by 3, what is your right hand side? Your right hand side is minus 1 upon 2. And negative sign, again I am repeating, negative sign is present in numerator. So that's why there is no need to multiply and divide by minus 1. And this is again what called as the standard form of fraction. So first of all, we're seeing what is rational number. Then next few examples of rational number, and the main form of rational number, that is denominator must not equals to 0. And next is the standard form of rational number. Then let's see what is the absolute value of rational number. What is the meaning of this absolute word? So the absolute word means nothing but writing this. The absolute value is the distance from the zero on a number line. Okay, what we can call this absolute value as? It is the distance from zero on the number line. So if suppose we are just looking to this number line is given shown here in the picture. So what about the main body, this distance represents? So this body distance means that distance is always a positive. That distance is always a positive. Okay. So and after this, how we are going to represent this absolute value? So we are going to represent that absolute value by the symbol. Means in between two lines, we have to write down the number. Whose absolute value we need to find. So in between this symbol, we need to write down the number. Isn't it? So now let's see how we're going to find out the absolute value. Suppose I need to find out the absolute value of minus 4. So what I'm going to do here, I'm just going to write minus 4 in between these two lines. Now I need to find out the absolute value of minus 4. And therefore, as the statement says, it is a distance from 0. So if suppose I am counting the distance from 0, so this is nothing but up to the 4 units. This is nothing but up to the 4 units. But at the same time, yes, it representing the left side. So generally we are taking that as a negative. But here absolute value representing distance, and distance is always positive. This is very important thing. So therefore, what is your right hand side? So modulus means, or the absolute value means nothing but whichever negative terms are there, we need to take the positive form of this, because we are calling this as a distance from 0. So, and distance is always positive. We cannot measure the distance in negative, isn't it? Similarly, if one more example is there, if we need to find out the absolute value of plus term. So what we are going to do there? Yes, the absolute value of plus 3 is as it is plus 3 only. But if suppose we are considering any negative fraction, suppose minus 1 by 2, then what is the absolute value of this one? You need to put that inside the lines in the symbol form of absolute value and then write down the absolute value of this. So what is the absolute value of minus 1 by 2? The absolute value of minus 1 by 2 is equal to 1 by 2. So this is nothing but all about the absolute value of rational number. And again, this one thing that we convey here. What about why we are taking the example as 4 and 3? Are these your rational numbers? Yes, these are your rational numbers. Why we are calling this a rational number? Because 3 or 4, we can easily write down as 4 by 1. 3 again we can write down as 3 by 1. And all these are the integers. All these are the integers. So again, it is included in rational number. Next, let's see how we can represent the rational numbers on a number line. Just now we have seen the absolute value, and that absolute value we need to consider from 0. Only the positive term we are going to consider when we are finding the absolute value of any rational number. Then what about the rational number when we are going to represent that on a number line? So method is given here. You need to follow some steps. So first example I take it here. So my question is nothing but represent 5 by 9 on the number line. What we need to do here, we have to represent 5 by 9 on the number line. So first of all, you need to draw the number like this. It is shown in the picture when the same time you just draw this. So 0 is there and your 1 is there. In between 0 and 1, you just carry this. So y by line on the number line means what you need to do here, we mark the origin and integer value on the number line since proper rational numbers lie between 0 and 1. This is the main and important reason why we are taking that in between 0 and 1. Next, we divide this region. This region means which region? The 0 to 1. We are going to divide this region into equal parts. Now here, what are the equal parts we can consider? So look at the denominator value for equal part. What is the denominator in this one? So your denominator is nothing but 9. What is your denominator? 9. So how many equal parts we need here? 9 equal parts. How many equal parts? 9 equal parts. So after this showing it on a number line. So how we are going to start? This is 0 obviously. The next is 1 by 9 means you need to first of all mark all this part into the 9 parts. And then write down 1 by 9, 2 by 9, 3 by 9, 4 by 9, 5 by 9, 6 and so on up to 1 and your work is nothing but showing 9 by 9 because this is nothing but integer value. Isn't it? So according to that, you need to divide your region. And after that, 5 by 9, you need to represent on number line. And then this is a 5 by 9, this is 0, 5 by 9. And just put a dot or either you can represent that by any alphabet. So whenever you need to draw or you need to show any rational number on a number line, so exactly what you need to do here. First of all, just look at the denominator of that rational number. Then just draw number line. If suppose the denominator is like 5 by 11 or suppose 2 by 11, then how many parts we are going to draw now? So this one is 0 and this one is 1. These are the different rational numbers. So in between this, you need to mark 11 parts. Need to mark your 11 parts. And accordingly, the second part, this is nothing but 0 first and second. This is 1 by 11 and 2 by 11. So you need to draw. This is nothing but a representation of rational number on a number line. Let's see the next one. Okay, what is the meaning of equivalent rational number? Again, let's revise our previous all the topics. We see the definition of rational number. Then next is nothing but the absolute value of rational number. Then the standard form of rational number and the representation of rational number on a number line. Now, let's see the equivalent rational number each one. So, one example is given here. And if you need to find out the equivalent form, suppose 2 by 3 I'm taking here, then we'll see this example. 2 by 3, what is the equivalent form of this one? So, when I'm multiplying this and numerator as well as to denominator are the same term. So, this is my original number. So, this is my original equivalent rational. Then when the same rational number will multiply and multiplied by 2 to numerator as well as to denominator. So whichever the term I'm making, that is 2 by 6. So now we can say if 4 by 6 is the equivalent form of the original rational number. Is the equivalent form of original rational number. Isn't it? Then similarly, again we need to find out the equivalent form. So consider your original rational number and again multiply numerator and denominator by the same number. Okay, so here we are multiplied by 1, then we are multiplied by 2, now we are going to multiply by 3. Multiply numerator and denominator by same number. So what is this now? 6 by 9. Again, this is the next equivalent form of 2 by 2. These are called as equivalent form of 2 by 2. So like this, by using the same method, can easily find out the equivalent form of 7 by 8. So, as it is shown here, first of all, we need to multiply by 1 by 1. So, this is the original one. Then, when you multiply this by 2 by 2, it's not compulsory. Okay, you need to multiply by 2 only, 3 only. Some higher terms, if you want, you can take those terms also. So, but the number should be same, numerator and denominator. So, when you multiply 7 by 2, it is 40, 8 by 2, again it is 16. So, we can call this as the equivalent form of 7 by 8. Again, when you multiply it dividing 3, so equivalent form is 21 by 14. 24. So, like this, here it is shown. Okay. 7 by 3. What are the equivalent form of 7 by 8? 14 by 16, 21 by 24, and 28 by 32. Similarly, you can find out the equivalent forms again by considering the different norms. So, hope you have understood all these things. Then we'll move to next. So these are nothing but a few examples which is based on the equivalent rational number. So let's look at these examples. So in this, we need to fill in the boxes. So first of all, find out the equivalent form of this one. Again, we need the same concept of the previous one. What is 4 and minus 12? What is the relation between 4 and minus 12? So here you need to multiply 4 by minus 3. Then you only then get it minus 12. So same is there. Equivalent fraction we are going to set it because equal sign is there. And therefore, if you are multiplying numerator by minus 3 by the same number, you need to multiply the denominator as well. So 5 again we are going to multiply minus 3 and what is the answer there? So the answer is nothing but minus 50. The answer is nothing but minus 50. Similarly, now just forget about this one. Now find out the relation between 4 and 20. We need to find out this one. So 4 and 20, what is the relation between 4 and 20? So when we multiply 4 by 5, we'll get 20. So same thing again. So we are multiplying numerator by 5. So same, we are multiplying denominator by 5. Get 6 plus 6. So same operation we need to perform with numerators. So whichever the term is there, we need to multiply that by minus